So my name is Jon Ericson. I am currently the Communities Manager for OpenSSL Foundation. In the past, I was a Community Manager at Stack Overflow and a few other places. And today I'm going to talk about what might have been the worst day in the history of the OpenSSL community, and perhaps also the very best day. I like to start my talks with the OpenSSL mission. I'll just read it. We believe everyone should have access to security and privacy tools wherever they are, whoever they are, wherever they are, and whatever their personal beliefs are as a fundamental human right. And this formulation is relatively new for the mission, but the belief system, the idea that we believe everyone, wherever they are, whoever they are, should have access to these tools, it goes back to even before OpenSSL was thought of. So let's go back to the Mesolithic era of the internet, when the World Wide Web was invented. And the World Wide Web depended on the internet protocol. You pass packets back and forth from one server to another, and anyone along the path can open the packet and see what's inside, right? And there's nothing to prevent anyone from seeing the plain text. And this is actually sort of a feature of the system because it's open by default. The idea is if you have the URL, you can get the information. We want information to be free, right? We want everyone to be able to find what they're looking for, and that's great. And it was started by research institutes who really wanted to share information. But what if you want to sell stuff on the internet? I know it's crazy, but imagine if you sold books by going to a web page and then the books would be delivered to your house. How would that work? Well, one problem you'd have is when people send their credit card to you, anybody along the chain could read your credit card information, and that would be bad. And then things like they would be able to find your home address, because how do you get the books to the home or the office? That's also bad. So there's a lot of places where you just don't want your information to be completely free and available for anyone. You actually want it to be very limited to certain people. And so this was a problem that was actually solved by a company called Netscape back in 1995. They developed an early browser and an early web server, and they invented something called SSL. Doesn't matter what SSL stands for. One of the S's is for secure, and it meant that all of your packets or passed back and forth would be encrypted. So if someone grabbed your packets, they couldn't read it and figure out what your home address is or the very private email that you're about to send. And considering that I was thinking about I have a new laptop, and I thought about all the things I had to install, and I was like, okay, so I'm going to install Firefox. Okay, that's it. I mean, obviously a few other things, homebrew and such, that I use for developing. There's a little problem, or there was a problem in the mid-90s, and that's that the U.S. government said this is a military technology and you cannot export it outside of the U.S. or Canada. So think about our mission, wherever you are. This is what the world looked like in '95. There's strong encryption for everybody in kind of that section up there. And everyone else had sort of weak encryption. And by weak, I don't mean just that the NSA could figure out what you were sending. Weak meaning like someone with a regular desktop computer in a few days could extract your information. So unless your secret is very time constrained, you have a time limit on it, that's not very strong. And by the way, this isn't even explaining all the problem, because if your browser that you purchased is in the US, but you're speaking to a server that's outside of the US, well, you're getting weak encryption. You're not going to get strong encryption. That's a big problem. And so someone decided to solve it. In fact, two someones who happen to live in Australia. And these guys, Tim Hudson and Eric A. Young, invented a system called SSL-EAY and made it open source. And this is a very common thing in an open source project, right? You see something you want, and you can't have it, either because it doesn't exist, or in this case, you can't have it because you don't live in that certain geographic region, and you build it yourself. And then instead of just saying, oh, I've got this thing for myself, you say, well, I built this and I want some help building it and doing more, and so I'm going to make the project open source, and other people can contribute. And you kind of conquer, right? If you've ever played the game Risk, Australia strategy, which anyway, it doesn't actually work in the game Risk, but it worked great for SSLEAY, and so it just spread everywhere because if weak encryption or strong encryption, which would you prefer? Oh, okay, I agree. Strong encryption it is. And then because SSLEAY was used in other projects like Apache and Perl and all sorts of other things, it actually went and kind of conquered the US too, right? Because if you're building a free and open source project, would you rather use SSLEAY, which is open source, or would you rather use Netscape SSL, which you had to pay for? A couple of caveats on this. There was still a lot of Netscape SSL around, right? Because if you had purchased Netscape, either the server or the browser for some reason, like I did when I was in the 90s, then you'd use SSL from Netscape. And it just is the natural thing. Fortunately, they talk to each other. The great thing I didn't mention before, but Netscape had made the standard available. They'd published their standard so that other people could communicate to their SSL. And then the founders of SSLEAY left to join RSA. So now you've got a great open source project, and the maintainers have gone off and done something else. And so what do? I mean, this is a problem, right? Well, it turns out it wasn't really much of a problem because there's a community on the SSL users list. And so that community said, hey, we can just fork the SSLEAY code, and then we can scrape off SSLEAY from all the files that have it and put OpenSSL back on it. And they released it. This is actually Take 2, the email for Take 2 that happened in January of 1999. And you can see they nicely credited the founders of SSLEAY, and they actually made the license a little bit nicer. It's an Apache-style license. So in other words, OpenSSL was able to just sort of take over where SSLEAY left off. It's everywhere. It does all the things. It's not just the web anymore. You can use it for email. You can use it for just anything you can think of where you're transmitting data from one place to another. I talked to a guy who was working on serial port communication, which was great. I was so excited about it because I did this when I was an intern at the National Weather Service. And he has an OpenSSL connection so that you can actually connect to a serial port over the internet, which I was like, wow, I wish I had that back in the 90s. So that's the end of my talk, right? Because open source won, OpenSSL has conquered the world. Yay, team! But there's a problem. This is what I consider the worst day in the community's history. And this is the front page of the New York Times. Not the top story, but still on the front page is this story about this problem with these websites, right? What is this? It actually says it later in the article, but not in this section, the headline. It's Heartbleed. How many of you have ever heard of Heartbleed? Yay! Heartbleed is amazing because it means that all sorts of people know about OpenSSL all of a sudden, right? So the downside is I was working at Stack Overflow at the time, and our system administrators were like, oh no, what are we going to do? Because we had a lot of servers, and almost all those servers had OpenSSL underneath, and all of them need to be patched. And then you need to make sure that your patch actually was fixing the problem, that you had actually done all the steps. And there's news reports about how people should change their passwords and how they'd lost, potentially lost all their data. That actually probably didn't happen. There probably wasn't a huge amount of data. We can't know for sure because there's no way to know. because of the nature of the bug, but it cost a lot of time, and it gave OpenSSL sort of a bad name among the general public even. We're not talking about tech people, we're talking about people who read the New York Times. So, yeah, I mean, it could be both, right? But I see what you mean. Here's my diagnosis of why that happened. The OpenSSL community was not keeping up with the popularity of the project itself. OpenSSL was used everywhere by all sorts of people, and the community, this is the number of people who've contributed some sort of commit each month, and I've got it all the way back to 1999, and the pink line is the 12-month average, and you can see it's around 5 people, goes up and down, 5 people for this project, but that's not even telling the full truth because the number of people who are actively maintaining it was closer to 2 or maybe like 1.5. So it was not a lot of people who were actively maintaining it, and the community was sort of stagnant. Like you're not seeing anywhere near the growth compared to the usage, right? Okay, so let's ask the next question. Why is that? I took this picture a couple weeks ago. It says Mojave Yucca community. I thought it was amusing because this is not looking like a very healthy community. It's all prickly and dry, and unless you know what you're looking for, you can't even see the Mojave Yucca. They're actually these 2 sort of stump things. They're supposed to have these big green leaves. They look amazing, but these do not look amazing. They look prickly. And I thought this is a good representation of what the community was like before Heartbleed. Cryptography is intimidating. People, think about what happens if I start working on this project and something breaks? What happens if I start working on this project and I create something that's not secure? Oh my goodness, that's a lot of responsibility. And so not everyone feels like they can do it. Not everyone feels like they can contribute to OpenSSL, and that's true even today. And not everyone can contribute code either. And this is maybe even a little bit harder for a project like OpenSSL, which is mostly written in C. C is a fantastic language, but again, it's intimidating. Not a lot of people, a lot of people know it, but there's even more people are excited about other languages. Lost my train of thought. but C is not exactly the easiest language to work with for a lot of people. And then there's Perl. I love Perl. Perl is amazing. A lot of people don't like Perl, right? Perl is nicer than C, right? Well, not for some people. And then there's a sort of a caveat, which is that the Perl that's used in OpenSSL is used to generate assembly code. So if you're excited about Perl, I'm sorry, you're not actually writing Perl, you're writing a Perl generator for assembly code, and that's breaking my brain just talking about it. Imagine trying to work on this project. And so these are intimidating things. How many people could do this, right? And then the other thing that's going on is the people who are maintaining the project are really into it, right? They're really excited about it. Are they thinking about, how do I bring new people into this project? No, they're thinking about, how do I avoid having people try to kibitz and tell me this is how you should do it, right? That's a bother. It's taking them away from the code. And then the other thing is the community happened on mailing lists. Again, I love mailing lists. There's email to, that was the way things worked in the 90s. But mailing lists have a problem, which is that you kind of have to get involved in it, you kind of have to read the mailing list a while, otherwise people are yelling at you. And then you're submitting patches over email, all that sort of thing. It's not that it's impossible, it's not that you can't do it. It's just another barrier that makes it slightly harder for people to get into the project. So this is actually the picture I took. I cropped it down to just the fun part. But this is the bigger picture, which is, you can see there's more variety. There's more stuff going on. You can actually see a Mojave Yucca with a green thing sticking out. I love this picture. Some of you may not love the desert as much as I do, but I come from Southern California, and the desert is my home. And this is a great picture. And what I like about it from a metaphorical point of view is that it's not just the Mojave Yucca community is not just Mojave Yucca. And the OpenSSL community is not just the maintainers and developers of code of OpenSSL. There's actually a lot more going on here. And then the other thing is Mojave Yucca, one of the ways that they are able to thrive and reproduce is they depend on fire. So when fire comes through, it makes it easier for them to spread the seed around and grow and expand. Sometimes there's a necessity for creative destruction in life. So this is a change. Anyone know where a Heartbleed bug happened on this graph? It actually happened a little bit after when people started becoming more active. I haven't really figured out exactly why, but you can see that before Heartbleed, you would go literal years without anyone new joining the community, and since then it's been going up and up and up. And that's great, right? This is how a healthy community survives. People like order. So this is actually a different picture in near Nevada. And there's a Joshua tree. And there's an art installation. It may not be possible to see all the way in the back, but there's this cool art installation of someone has put up stones that make these towers. And a bunch of people have come out to the desert to see this. I recommend it. Oops, I accidentally pressed 2. This is what the community looked like in 2015. So still mailing lists, but now there's a wiki, and it's on GitHub. And I honestly think GitHub makes a big difference for a lot of people because instead of having to go to a mailing list, learn how to make your patch, follow the rules of this individual community, GitHub streamlines a lot of that, right? We all know how to create an issue on GitHub. We all know how to create a PR on GitHub. There's still some nuance like from project to project, but the interface has actually helped. It creates a sense of order in the community that means that people are more likely to join. Another thing we did was we started adding tests. So I don't know if you can see it really well, but that top line is the code increases over time. There's actually a logarithmic graph, so that's not a weird shape. And then there's tests, which is the green, or tests, which is the pink line. And after Heartbleed, there was a real focus on creating a testing framework and creating some tests. And that actually helps contributors a lot because you don't have to know the entire code base to make a change. If I make a change in one part and I test my part and it seems to be working, it's doing what I think it should, and then I run the test suite and it didn't break something else somewhere else, I have a higher sense of confidence that my change was actually a good change. And not only that, but the maintainers can look at that test case or the test suite and say, okay, it didn't break any of our tests, and they can feel a little bit more confident that that the code is worth bringing in. Heartbleed was good for the community. Communities that don't grow are in the process of dying. And so this is my favorite graph because it's showing that the OpenSSL community is growing. And there's just a million different ways that that's happening, right? Here's some things that, that we've done in the past year that has happened in the past year. I started a survey to find out where OpenSSL is being used. And we had a conference in October. That was amazing. More recently, we had an AI, a company that does AI find a bunch of vulnerabilities in our code. And one of the things I like is that they say that it's hard to find, it's extraordinarily difficult to find vulnerabilities in OpenSSL. And why is that? Because the community has gone through and fixed a lot of things. That doesn't mean Heartbleed is impossible in the future. It means it's less likely. This is a picture I took just today. I don't know if you can see it. Homebrew has their thing, and the example that they gave is brew install OpenSSL. I don't know why I think that's so cool, but I think it's awesome. I want to say thank you to our supporters. We are the OpenSSL Foundation. We depend on these supporters. The supporters allow me to come to this conference, which is not cheap because I come from California. The conference itself is cheap, but coming isn't. And I'm now ready for questions, but while I'm answering questions, please scan my QR code so that you can get access to the newsletter that I am definitely going to be writing tomorrow so I can get it out this week. This is a brand new thing that the OpenSSL Foundation is doing, and I'm writing it so you don't have to worry about it being spam because I'm lazy, and I'm going to be pushing every month or every couple of months to push one out. All right, we ready for questions? Oh, thank you. Over there, I think.
Hi. One thing I noticed about the Heartbleed bug was that the code was committed at like 11:30 p.m. on New Year's Eve.
Yes.
Do you think that was a factor?
Well, I wasn't there, so I can't say for sure. But I don't think that was a positive thing. And it's just when there's a small number of developers and you're getting some code coming in, and this code came in was actually part of the Heartbeat feature, which is a good thing, right? You want to bring that in. It wasn't like someone was dumping some dumb thing in. But it makes it harder when there's only a small number of people and they have to frantically look through the code or let someone down, right? So I think having a very small number of maintainers is a potential problem for projects. And so the maintainers themselves should be incentivized to grow the community so that it's a bigger group of people looking at each of these things. Yeah.
So it's really interesting and good to hear the story told from someone who really knows it well. Tying into some things we heard on the main track this morning, how do you protect the mental health of your contributors? Because you go to the Wikipedia page, the guy who put in the commit that broke things is named. I mean, that's really rather scary. I'm going to commit this. Oh, suddenly I'm the world's sort of villain. How do you look after your community to protect them from that, frankly, unfair, I think that's a polite way of putting it, way of being treated? You didn't pay for it.
That's a great question. So one thing for me personally is I don't know the name of the person. I mean, I looked at it once and I was like, I'm going to forget this. Because I do agree that there's a sense of shame, right? I think the other thing is there are more people in the loop. So there's 2 reviewers for the code. And so it's actually, there's more people who have a sense of responsibility. You kind of diffuse the responsibility a little bit. I don't know. I mean, I think there's sort of safety in numbers. So, right, the more people that you have involved, it's helpful. And then I personally just would never want to make a big deal about this poor person because it's a potentially very shameful thing. Is there time for one more in the back?
Thank you for your involvement, and as someone who worked at a university who had to deal with this on a large scale, it was very interesting. I'm wondering to what extent you would measure the health of a community based on the percentage of tests that are in your product.
Percentage of tests. I mean, so I add this. This is still not enough tests, I'll tell you that. So we're at about 70% tests. There's sort of a point where you diminishing returns where like you're testing things, lines of code that are just not getting run very often. It's more work to create the test and very low impact on it. So there is definitely a place where you just reach diminishing returns. We're nowhere close to that, right? And I think the other thing, I didn't mention too much on this graph, but the documentation is actually perhaps a bigger problem right now because the tests help you verify that the code is working, but from a community perspective, we want people to contribute code, and if the documentation has not reached the level where people are able to contribute code fairly quickly, then we have a problem. And I think I've heard this a lot, that the OpenSSL documentation is hard to use, and I agree. I'm fairly new to the project, and reading it, it's just hard to get into. It does what the developers need it to do, which is great. So once you're inside the community, it's fantastic. But but it's hard to get in through that. So, I mean, I didn't really answer your question with a number. It's above 70, less than 100, right? and I think, I don't know, my 90 would be great. 80 something would be pretty good too. Yeah.
Thank you. We're at time.
Okay, great.
Thanks, Jon.